It is my pleasure to welcome our friends from Fidelity Investments to talk to you a bit more about their strategic deployment of over 1,000 applications. Please give a warm welcome to Sean Donahue, Pete Davies, and Jen Hayes as they join the stage.
Thank you. All right, we were expecting to stand, so this is going to be a little weird, but good for us. So, Pete, I noticed that you don't have a little badge by your name.
I don't. It's very true. I am happy to say that as JR spoke about this morning, FinOps is for everyone. I represent part of the everyone. I do not have a financial background. I have an engineering and architecture background. So it's terrific to be here today and think about how architecture practices and engineering practices can lead into better FinOps practices and vice versa.
Yeah, excellent. And just one little thing, Zach Stitham, who is in the back, everyone say hi to Zach Stitham. He isn't going to be able to make it with us today, but we will do him proud. You know, 5 years ago, actually, Zach and I stood on a stage very much like this at CloudyCon. I don't know, did anyone go to CloudyCon here? The precursor. We got two in the back, one in the front, one in the back. It was the precursor to FinOps X. And Zach and I presented there, and we talked about some of the challenges that enterprises were going to face adopting cloud optimization activity in FinOps. You know, a large enterprise, one that has existed for 70 plus years like Fidelity has, have a lot of cultural and legacy challenges that they actually have to deal with when you're thinking about cloud cost optimization. And so our hypothesis at the time was you really had to leverage the current organizational structure that was there and try to figure out how you embedded the practices, the processes, and shift left as much as possible, really within the engineering and the architecture organization, if you really wanted to really reduce the cost of the cloud itself. And so that was our hypothesis, and this is our story of the last 5 years and what we have done to really make that shift. So I want you guys to think for just a second. What would it be like? What would your FinOps practice be like if you didn't have to worry about 80% of your application portfolio? If it was running well enough and optimized enough that you could put your focus on the 20% of your portfolio that was probably the most different, probably the ones causing the most expense or forecasting to be generating the most expense. What would that be like for you? How would that change the way that you went across FinOps? And that was the challenge that we took on. We looked at it and thought, if there was a way for us to not have to worry about every single application in our portfolio, and I think we're close to 1,700 applications in our business unit alone that it runs on the cloud, what would that be like and what could we achieve? And so I first want to introduce Pete Davies here. So Pete came to us from Capital One about 5 years ago, I think 5 years ago, like next week.
Next week.
He helped lead their migration to the cloud. And when he came to Fidelity, he brought a lot of the learnings, both the good and the bad. And so we used to have a lot of discussion at the beginning about how it is that we could leverage our entire organization, because organizations are really rich in a lot of different knowledge, a lot of different practices. For us, we have things like our enterprise cloud organization that really provides some really good fundamentals that we can build upon. And so Pete and I would have these really long discussions about strategy itself and about business scale. And I think, you know, one of the first things that we talked about is what did the business need and what did they mean from scale versus engineering, and what do we need from scale? So Pete, why don't you talk a little bit about business scale itself and how we support it?
Yeah, absolutely. So when we think about business scale in a digital business, we really think about feature delivery for our customers. Right? In the end, retail customers, whether it's Amazon.com, Walmart.com, any number of places, or Fidelity.com, have a high demand for new capabilities, new ways to invest, new products. If we liken that need, and ultimately, when we develop those new capabilities, we have to think about both the cost to develop them and the time to market, right? And those things are really critical. If we liken that need to building an automobile, modern automobile has tens of thousands of parts, okay? And there are manufacturers out there that will build each one of those parts as a single thing. They will implement it within one vehicle type or one vehicle itself, and then end up having over time to maintain that whole set. When we think about a large-scale automobile manufacturer, and we have an example here of Volkswagen. Volkswagen is not just a brand, it's several brands, right? Audi, Porsche, et cetera. And the way they've actually implemented their business in order to drive scale is to create a set of parts that are reused across not only multiple models, but multiple makes of the automobiles themselves. Never before was this really brought out to me, and then at one point, I actually brought, several years ago, an Audi in for servicing to a Volkswagen dealership. And the service manager said to me, "Hey Pete, would you like the Audi brakes or the Volkswagen brakes?" And I said, "Well, what's the difference?" He said, "The part number and $200, right?" So that's really the key, is being able to drive down the cost and reuse those component parts when we think about each of these cars, very similar to a feature in terms of our delivery.
Yeah, so this Volkswagen facility that we have on the picture, actually, it can produce a single car in 2 minutes, right? Every car, let me change that. It produces a car every 2 minutes, and it can do it in 1 million different variations. So kind of think about that, right? From a customer experience, it feels very unique and different to that customer because they were able to do a lot of builds. But from a Volkswagen perspective, it is actually just the combination of parts that they have declared and made declared to be used with us. And so it's a really big, powerful story that they have. And so when you build something, we all have applications that we support that have been built, but really you have to figure out how to maintain them over time, right? So maintaining 1,700 applications in the cloud can become very heavy and over time and really weigh down a business. So we had this conversation again about, let's go back to cars, fleet management. So tell us a little bit about fleet management and why it's so important and how it builds on those concepts you were just talking about.
Sure. If you're a car manufacturer or car rental service, any number of those things, you have a fleet of vehicles that you have to manage and maintain, right? They may be owned by individuals here in the room, but ultimately they have to stock parts, they have to ensure that there's availability. We think of our application portfolios in the same way, okay? The further we can limit the number of parts that go into that application portfolio, the simpler it becomes, okay? The more it's differentiated, the more we look at a portfolio and say, hey, we have 1,000 applications or 1,700, and they're all different, the much more difficult it becomes to manage and maintain.
And so what are the really things we're looking at is how do we efficiently manage this portfolio of applications over time? And the big piece is budget, right? You have to do it not only efficiently, you have to create a stable environment, but you also have to do it within budget and continually improve on those economies of scale that the business really needs for them to succeed. So key to that is paved paths. What are paved paths?
As we thought through this very deeply, we said, okay, what are those parts and how do we actually build with them? We designed a set of paved paths. It's a relatively small set. It's not huge and complex in and of itself. But in essence, we asked all of our engineers who were building certain types of applications to reuse and leverage the paved paths that we built. Now, that actually gave us, very similar to our car model, a set of reusable parts that we can manage and maintain very easily. It's also critical as part of this to think about what we call opinionation, okay? There are ways to go to the cloud where you look at it and say, hey, we're going to let every delivery team go to cloud and engineer their solutions however they choose, okay? You end up in that way with a very highly complicated environment. Back to my example before, that's very, very difficult to maintain. On the far other end of that spectrum, you can say, we're going to cloud one way and one way only, and every application has to fit in that square box. And the reality is the developers hate it because they don't have the freedom to actually build certain things that they need to build, and it becomes very, very constrained. As we thought through this process, we thought for every point of our development, what should be opinionated, managed by a central team, controlled through this set of parts, what should be given out to the development groups as a whole, right? And where they can make their decisions.
So paved paths became part of our technology strategy right from the beginning as going to cloud. And I'm not saying that you can't start to adopt this, but it is easier as you're starting to move to the cloud. But it was core to our technology foundation. So Pete, talk about how it actually drove decisions within the technology strategy.
So when we thought about our tech strategy, we said, okay, if we can have 80% of our fleet roughly running on some of these paved paths, it allows us to think about that as a whole, right? And to the point of FinOps, it allows us to think about that as one very linearly scaling activity. We'll have more applications, but we know very, very well what they cost. We've built many of them of this type. It also, we want to reserve the 20% for some of the differentiation and innovation, okay? Now in that space, that's where we focus FinOps, right? We look at where there's innovation, differentiation, AI, ML activities spooling up, things like this. We can hyper-focus in those areas. I think that's one of the keys is that balance. And when we fell below 80%, we looked across and said, okay, is there a paved path we're missing, right? Is there, say, 50 squads out there that are needing to develop something, they're doing something very similar, and we can build that centrally and hand that back out, right? And then we can fully understand the costs associated with that component as part of it. The second piece is the design piece, right? So these paved paths, as we think about them, have to have a high degree of productization. And what do I mean by that? They have to be discoverable. They have to be incredibly well documented. They have to be self-service, and this is key, okay? Developers, development squads don't want to sign up and get on somebody else's backlog waiting for them to help them on board to a paved path, okay? It's really critical, and by the way, when that happens, the team that is actually building that paved path gets overwhelmed, right? So it's really critical that developer squads can operate independently and leverage this set of paved paths.
Just a quick question here. Did we force people to use
We
our
did
paved
not,
paths?
and that's a key component to this. We also held the philosophy that developers should want to develop these paved paths, right? And if we create centralized components and developers don't want to use them, then in essence, it becomes this large uphill battle, forcing adoption through KPIs and things like this. When you do that, there's this pulling sound, right, where developers want more and more from the centralized team to adopt these paved paths, and it becomes much, much easier. So we then focused on the ecosystem, right? And in the ecosystem, we think about, okay, we built application components, but then we have to think about all the surrounds around the application components that make it easy to take code out of the repository and actually put it into production. So what's in that ecosystem? CI/CD pipelines. Deployment, scanning for security, things along these lines that were much more standardized. And then after that, we took another step, and Sean's going to dive into this even further, of how do we think about testing, performance testing, functionality testing, things along these lines, right? So we built all these capabilities. And one of the keys, back to developers wanting to, we really only built them in the cloud, okay? Because that's where we wanted people to go. Right, so we didn't spend a lot of time building them on-prem. In fact, we didn't build them on-prem at all. We said, hey, we want the gravity to be out here in cloud. We want it to be a pulling effect to get people there. It's a carrot, not a stick philosophy. We also stood up and formalized 3 different disciplines, SRE, Site Reliability Engineering. By driving consistency, we are able to build code to actually operationalize our environments. It is much easier for somebody with an engineering background to write a loop to manage 1,000 applications than it is to hire 20 people to manage 1,000 applications, right? We don't like the playbook concept, we like the automation concept. Platform engineering. This is a centralized team that builds these components, manages these components, manage them as products. And the third component is product management. And the product management piece is critical to think about the roadmaps of the components, the needs of the developer teams, and how that goes forward. We not only had these within the business unit, we've been building out these teams across all of Fidelity, right? And thinking about how those different disciplines spread and interact within our ecosystem. And with that, I'm going to introduce Sean Donahue. I almost said Downey, the third time. I told him in practice I wasn't going to do that. Donahue, who was product management over this environment.
Awesome. Thank you, Pete.
So Sean, just one thing that I want to touch on, and I know you're going to touch on it a little bit more, but why these paved paths are so critical, right, is they create a very consistent environment for us. And Sean's going to go into what these environments look like. But that consistency is crucial because it means it's very predictable. Our production environment is very predictable, and anytime we make changes to it, we know how it's going to react because we know exactly how it's been implemented in these core functions. And so Sean's going to take us through some of what that looks like.
Awesome. Thanks, Jen. All right, so we heard Pete talk about the importance of opinionation. So with that view in mind, I want to take a look at our most common paved path, and that's the second generation of our container solution. This second generation solution is actually an enterprise offering container solution for Fidelity. The key to all of this is to have standardization across all the capabilities that make up the solution, starting with the base container image. Our container solution is a Kubernetes-based platform for application deployments. It's based on the GitOps model for application lifecycle management. There are standard CI and CD build and deployment mechanisms, and the tooling has the proper controls to allow the applications to be safely deployed to the production environment. The key to all this is the consistency across all facets of the solution. This consistency is what gives us the confidence to safely predict how an application will respond when we do our management and optimization activities. So this slide here is a bit of an eye chart, and our intent is not to go through every single detail. What we want you to take away from this slide is the end-to-end experience a developer will get when they adopt one of our paved path solutions. This is a continuation of the prior slide. This is an example of our second generation container solution. We've talked a lot about the advantages we get from paved paths in terms of predictability, but there's another key advantage here as well, and that is that it removes the technical burden from the application teams using our solutions. Our vision is that application teams can focus on their business deliverables while we take away the technical complexity from their solutions. So in the example of the container solution, our ask to the customers is simply bring your own container. Our solution will provide everything else you need to take that container and deploy it out to the environments. When a developer uses our self-service capabilities to onboard, automation is in place to stamp out the required plumbing to allow the developer to hit the ground running. Things such as service accounts are created, source control repos are created, the deployment pipelines are created to deploy that container out to our enterprise Kubernetes platform. And there are manifest files created for the developer. Going back to Pete's conversation earlier, we need to allow the developer enough flexibility to do their job. Developers can come into these files and update the default values provided to suit their individual needs. At the end of the day, the out-of-box experience provided by this solution allows us to save money in our most expensive area, and that's in developer cost. Our conservative estimate here suggests that every developer onboarding an application onto our platform will save 20% of their time for every application they onboard to the platform. And to date, we have 1,200 applications that have been onboarded to this platform. All right, so what do you need to be successful here? You need to build the trust of your business and development communities. These are our customers. For our business unit, our customers are our internal development teams and the businesses they support. It was also important for us to not overreach. We intentionally focused on one CSP with one technology with a goal to get good at it. From there, we could prove to our customers that we could be successful and expand on our offerings. In terms of patterns, it was also important for us to start small. So early in our cloud migration journey, we were looking for ways to get momentum in getting applications deployed out to the cloud. The approach we took was to examine our portfolio to see if we could see patterns of applications in our portfolio. Going back to Pete's conversation about fleet management, we were focused more on areas that gave us commodity rather than innovation. This initial evaluation identified these three areas where we felt we could get the biggest bang for our buck. So they were containerized applications for web apps or experience applications. Second were containerized application for our API tier. And third were databases that had similar requirements or profiles. Our analysis suggested we had many applications that could align to one of these three patterns. So we decided to start here and start building solutions for each of these areas. We started with the easier stateless containerized application solution and then progressed our way to the more complex database patterns. And each of these solutions, we worked with folks who are
willing to be early adopters and worked with them to gain requirements and use them to help harden our self-service capabilities so that we could then roll this out to the broader community. At which point, we built the carrot. We had teams queuing up their applications to use our solutions to get out to the cloud. But to Pete's comment earlier on, we knew we could do more. We had a goal of 80% of applications being able to use one of our solutions, and with just 3 available, we were short of this target. So we began to meet with the squads that had applications that were not candidates for one of the first 3 patterns, and we wanted to meet with them to understand what were their tech stacks, what were their requirements to get their application to the cloud. And from these consultations, we started to identify other patterns that we could add and build opinionated solutions for. We have 9 to date. Some examples of other areas we added support for were transactional batch applications, event-driven applications, among others. But we weren't happy with that. We reached the goal of having solutions for 80% of our portfolio. At this point, we pivoted our thinking and started to focus on building out an ecosystem of self-service capabilities and tools that these pay-pass solutions could use. These capabilities were all cloud-based capabilities. We did not build these for the applications that remained in our on-prem data center. And this whole concept, this whole notion of an ecosystem goes back to the idea of treating these solutions as products with full product management support. We meet with our customers on a regular basis to understand where are their pain points and what friction do they have. And from these conversations, we tried to identify areas where we could continue to make their lives easier. So some things that we've added support for are traffic routing capabilities, which Pete's going to go into here further in a bit. We also added support for standing up ephemeral environments to do things such as performance testing, ephemeral environments to run chaos experiments. When the teams are done with these tasks, we can tear down the infrastructure. Optimization was built into these solutions from day one.
And yet, we still saw opportunity for additional optimization. This goes back to what JR was talking about. We think we run, and it turns out we're not running at all, and there's always more opportunity for it. So one of the things that we continue to see is still excess provisioning of resources. And so we started to really have a conversation about why is it that we are still seeing resources, applications provisioning more resources than they actually need with it. And fundamentally, when we think about capacity management, which, by the way, we shifted the responsibility for capacity management away from a dedicated capacity management team in the data center to a DevOps model with the engineers being responsible for it in the cloud, right? And so fundamentally, capacity management is about risk management. And we had shifted responsibility for risk management to the engineers. And what are they going to do if they are responsible for risk? They're going to minimize their risk by over-provisioning, right? And so for us, we started to think about resource management and what would happen if we thought about resource management as a risk management instead and really enabled the engineers to have the control that they needed in order for them to feel more comfortable with risk reduction. And that would lead us, hopefully, to better resource management. So that was our hypothesis. And so we started to build out an ecosystem for resource management. We're not going to talk about every single one of these, but we are going to talk about 4 of them and how we actually believe they have led to cost optimization. Oops, they told me not to do that. All right. The first thing is address the risk. So someone came out and said it, right? You have to reduce the risk. For the risk for us, it's volatility and scalability. So Fidelity Investments firm is very market-driven, right? So when the markets are open, that's where we see our volumes come in. And if you'll notice on these charts, they don't ramp up slowly. Our volumes come in like a waterfall, right? So at 9:30, you turn on the market, and our volumes skyrocket. But it's pretty predictable. Every single day, we see volumes skyrocket at 9:30, and then it takes a little bit of a lull, and then right before market closes, we see another peak, and it comes down. So this is predictable for us. There are things that cause a little bit of an increase in volume, but those are predictable too. Triple witching day, in case anyone wants to know, it's an awesome day I can talk about. But things like standard business processes that occur quarterly, end of year, we can predict all of those from a volume perspective, right? So we can help them reduce the risk from predictable events. But then there's unpredictable events. So you see the bad errors, right? Those are the predictable events. You see the red line at the top? That's our high water mark, right? That's an unpredictable event. So we've had those. That is a true high water mark. So market-driven, the meme stock hit that high water mark, and so did the Brexit issues, things that we could not predict, along with things like DDoS attacks, outages, server outages, or service outages, application outages. Those are unpredictable events, and we had to give the engineers the tools that they could feel like they could manage their application in this scenario, in all these different scenarios, so they didn't feel like they had to over provision. Because the last thing we wanted them to do, which is what they would have done on premise, is provision to the high water mark, right? We don't want that much of excess capacity running. In fact, we don't even want the market day volume running, capacity running during the night. So that was our goal, is to address the risk. So we did it by providing them a lot more granular control of resource management. We could talk about auto-scaling, but you all know about auto-scaling, right? At default, we had auto-scaling turned on, but it wasn't enough. So we introduced these other two things and put a lot of time and effort in making sure that we had really good control systems around it. The first one is time-based scaling, and the second is traffic management. So Pete, why don't you tell us about time-based scaling and why it was needed versus auto-scaling?
Yeah, so as we all know, as Jen mentioned, we understand auto-scaling. It's a reactive mechanism, okay? It reacts to volume of traffic. But given the spike that we have at market open, we can't react that quickly. And what we saw happening was that when we tried, development teams, to Jen's point about risk, immediately stood up more instances to ensure that they weren't actually getting auto-scaling. They were actually floating above that curve for the day. To handle this problem, we started thinking about how can we give developers, and at least in the applications that we've identified, roughly 110 of them that are impacted by this, the ability to span out right before the market opens, right? And we gave them a coding opportunity that basically says, hey, with this configuration, I need to participate in pre-market auto-scaling, or pre-market scaling. And roughly at 9:15 every morning, we scale out the number of containers that are available to service our customers, and roughly 4:15 after market close, we start spooling that back off again. Now, we still have auto-scaling on top of that, right? So to Jen's point about the unpredictable events, okay, we'll auto-scale around those very, very nicely. But this was key for ensuring that development teams felt that they can actually manage that risk and still provide a cost-effective environment.
So I will say these are highly sensitive applications. This is not all of our application portfolio that we do it for. These are highly sensitive, and these are milliseconds that they have to be able to make transactions in order to place trades on the exchanges. So tell us a little bit more about granular control. And I don't think most people would think traffic management. Why is that a FinOps activity?
Yeah, this is an interesting one that we found. And you may have found this in your own environments. When development teams stand up a new version of their application, what do they typically want to do? They want to leave the old version out there for some period of time. Again, a risk management strategy to say, hey, we can always roll back to that old version. We actually saw requests for leaving the older version out for as much as 6 months. Okay, so if you can imagine the bubble cost per application of an overlap of 6 months of multiple versions lying out there. Now, take that idea and multiply by 1,000 applications, right? That simply doesn't work. So from a traffic management perspective, instead of doing our classic and traditional blue-green deployments, we started implementing more canary capabilities. So what does canary mean, and how do we do this, right? So in our default state, traffic runs 50-50 between 2 regions in AWS. Go one step further. When we deploy a new application into a new cluster, we actually move a small percentage of traffic to that new application. This allows development teams to verify that their application is actually functioning correctly through both their logs and functional tests, and also just understanding how it's impacting our customers. They're able to then dial that up to a higher percentage when they feel comfortable going forward, or roll it back at any particular point in time. Eventually, they get to 100% to the new application, and the old application is recovered. This process happens in more like a week than months, right? So that bubble cost has shrunk dramatically.
So in addition to that, right, they're instead of a blue-green environment where you're bringing up two identical environments, this allows you to auto-scale the new environment too. So you don't have to come up with it accepting 100%, the possibility of accepting 100% of customer traffic. It can be smaller when you start to the initial piece of it. It is also fundamental, though, to our ability to manage the applications on their behalf. And one of the things when we start to think about how big this is, this may be small, and we may just be reducing a couple weeks' worth or even a week's worth of cost on both sides of this. But we had 40,000 application deployments last year just in our business unit alone. And so think about this times 40,000 of these application instances, right? And so it really allows us a lot of management, a lot of that optimization period.
All right, so we also needed to react to unpredictable events, okay, whether it's DDoS attacks or large-scale regional issues. And we use very similar capabilities to be able to drive traffic from one region to the other. And we can rebalance from 95.5, 100.0. We actually do this under the covers fairly frequently. It happens in roughly 90 seconds. The nicety to this, again, is developers tend not to over-provision resources because they have the comfort that we're able to centrally manage from region to region and balance traffic back and forth. Again, it's given them a great amount of certainty.
All right. So let's go back to our product manager here, and let's talk about really what have we done, though, to optimize across the fleet from a cost optimization standpoint, building on these opinionated pipelines and our ability to move traffic and manage on behalf of the application owners.
Yeah, awesome. Thanks, Jen. So yeah, I want to get us to the finish line here, sharing some specific examples of the cost optimizations we've been able to realize because of the consistent, predictable nature of our applications using these solutions. So the first one goes back to early in our cloud migration journey in our first generation container solution. We wanted to make use of AWS Spot instances to help with our AWS ECS costs. So we decided to start a small POC in a non-prod environment. At this point in our journey, we were early on, we had maybe 300 applications on our platform. We wanted to do a POC to see if we could roll out Spot in a way that would be non-disruptive to our customers. And what we found was, because of the predictability and consistent nature of the applications in our portfolio, we were able to roll out Spot to all of our non-prod applications in a course of 7 days without any impact to our customers. The whole change was transparent to them. The net result of this was a 56% daily reduction of our AWS ECS costs in a non-prod environment.
So that was really our first opportunity to really demonstrate that we could manage across the environment for the benefit. So that's that building trust piece. Right. This was our first one that we were able to do. Yeah.
More recent one is the load balancer optimization. So again, in our first gen solution of the container solution, we had a model of 1 ALB per application. This implementation was due to the availability of CSP services at the time the solution was created. So as new CSP capabilities became available to us, we wanted to pivot to a shared ALB model. And because of the consistent, predictable nature of the applications in our portfolio, our engineers were able to go into the config files and make that switch to a shared ALB and do some preliminary testing. Now, this change wasn't completely transparent to our customers like the Spot was, but we were able to minimize the effort needed from the squads. Our ask to them was simply to redeploy your application at some point in the near future on a timeline that worked for you. That redeployment was made easier by some of the traffic routing capabilities, management capabilities that Pete spoke to. And with this approach, we were able to reconfigure and redeploy over 1,000 applications over a period of 4 months, getting us a conservative savings of 65% off our original load balancing cost. And yet, there's still more opportunity for additional optimization. The final example I want to share with you guys is from a recent hackathon event that was organized by our engineers that built these paved path solutions. It's an exciting place to be in your cloud journey when the engineers who are building these solutions are self-organizing hackathon events with the theme of addressing cost optimizations. And that's where we find ourselves with the team back home. So despite the optimizations we made to our container solution over the years, we still have a problem where several applications on the platform are heavily overcapacitized in terms of requested CPU. And our engineers sought to come up with solutions for this problem in the hackathon. So they came up with a solution they're calling Resource Shredder. The idea here is a process will be kicked off that will scan the production environments looking for the peak CPUs for the applications on the platform. When they find those peak CPUs, they're then comparing those peak CPUs against the requested CPUs in the application config files, seeing what threshold is being met. So we're starting off conservative in the early days here. We're starting off identifying applications that have a peak CPU that have not met 20% of the requested CPU in their config file. And when that condition is met, we're sending off a pull request to the squad suggesting a lowering of the requested CPU by half to start. Now, anytime we add a new tool or service to our ecosystem, there's an education element to this, and this is no different. So in addition to submitting a pull request, we're also reaching out to our customers, teaching them about this new tool that's in the ecosystem, and explaining our methodology and approach that we've used in submitting the pull request. We're in the early days of rolling this out, but we're pretty excited about the opportunities for optimizations we think we can realize with this. And we're happy that we have many levers that we can use to roll this out in a safe and conservative manner. There were other ideas that came out of the hackathon. Many of those ideas have gone into our backlog and will be picked up in future iterations. But hopefully these examples share with you how we've been able to realize optimizations for 80% of our portfolio because they're consistent and standard in the way they are built and deployed. So I guess with that, I'd like to close with posing the question that Jen had up front and ask the question, how more effective could your FinOps team be if they only had to focus on 20% of their portfolio?
And we're open to any questions that you might have.
Wow, okay. It was not that long the last session.
This should be a quick one. How much of a look back do you do for that CPU peak utilization? A week, a month?
We're doing 4 weeks, yeah. So we're starting with a 4-week look back at this point.
That is a variable, though, that we can change if we needed to. We do keep logs for longer than that.
And you said it's the early days. I was wondering how well received that's going on.
Yeah. I think, yeah, it's a good question. You know, I think a lot of it right now is just an education component, right? I think it goes back to the risk management. A lot of these teams are heavily overcapacitized because of risk, so a lot of it's education. We give them the data to show what their utilization is, and it puts on the light bulb. Now, you know, there's always, they might be planning for an unscheduled event that's coming up, and so might be, you know, it's where it's worth having a conversation to find out, is this your normal CPU that's expected, or you expected some unplanned, you know, event that's coming up where you need the additional capacity? But it starts the conversation, and I think that's the importance that we're getting out of it.
And we do go through this process of, this is about building trust again, right? So every time we do something like this, which is pretty major, we have to build the trust. And then once we build the trust, then they're very open for us helping to manage those types of environments.
You were showing that you're active for a lot of your applications, balance load type of approach to production, multi-region for active. Do you face any challenges around that, the risk of outages and incidences when it comes to, I don't know if you've heard that thundering herd risk with AWS, and I don't know how real it is, but it allows sort of that out for folks to provision two regions, right, the same amount of capacity for peak, because, hey, this capacity may not be available. That, you know, US East 1's the largest region, right? We all went to West 2, everyone who was on East 1, and you were provisioned at lower, you know, volume, then you had to scale up and it wasn't there. Right? Is that a real risk? Do you perceive that as a real risk? Do you do anything to account for that?
I'm assuming I'll take that one.
Yeah, you take that. The engineer take that one.
I think it's risk in everything, okay? So, and there's always a balance of that risk. What I would say is our FinOps practices actually help us with that risk, because when you pre-purchase reserved instances, right, you've already dedicated some degree of that capacity. And and it's sitting there for you, right? We have to balance that, obviously, across how many instances would we have in a particular region. I believe this is a fair statement, okay? So I don't really have the data to back this up, so I'm a little bit hesitant in saying it. I have not heard a lot of anecdotal evidence recently in terms of our systems having problems finding new instances in regions. But that said, we also use a lot of common instance types, right? So again, this idea of we're doing a lot of commodity compute here, right? We don't need some of the high-end esoterics for this set of our fleet, right? This portion of our application portfolio.
Yeah, let me talk about it a couple different ways. We did see some issues within spot instances, right, when launching and things like that. We can also control the engine types through this, through configuration files and push out new configuration files with the different types of engines. Our biggest high watermark was that meme stock, right? And during that time period, all the financial markets were under pressure, not just Fidelity. And we thought, okay, is this going to be a problem for us? Or are we going to run out of capacity? There was no running out of capacity at AWS. It was a market event, but it wasn't a worldwide event, right? And so, one of the things is we have talked about securing. There are different types of reserved instances, and you can actually secure it. We've never had to actually purchase those, so our eyes don't actually guarantee us access to those systems, right? But we watch them. And even during the high times of stress for our environment, it doesn't tend to necessarily happen at the same time for everyone else's environment. And I think that's one of the benefits of cloud is the diversification of the companies using it don't all come under pressure at the same time, right? Yeah, there's probably a lot of other stuff going on that we have to be worried about.
We actually, in that meme stock period, saw significantly more challenge in the data center than we did in cloud.
Yeah,
right?
our data center
We were
capacity
scrambling
was
for data center capacity
was terrible.
resources
Yeah,
at the time.
yep.
Thank you. So I have a two-part question. On the load balancing consolidation, did you have a grouping strategy? I'm assuming that not all of Fidelity is running on one load balancer. Part two, when you look at your aggregate of the platforms that are actually augmenting your ability to get to one of those complicated workloads beyond that step one, where you get databases and compute, are you also, how are you fostering self-service when a squad may not know chaos framework, or may not know limit performance testing? So is it more than just the platform, or do you have to bring other people to lower that barrier?
I'm going to take the second one first. I run an organization called Engineering Excellence, and we actually have people embedded in all of our squads itself. We do things like quality assurance best practices, automation, things like that. And we leverage that group of people to actually we teach them. We pair them around with the platform engineering group. They train first because these are complicated things, right? Performance management in itself, when you move it from a group that does performance management to a normal engineer, a lot of engineers actually don't know how to do performance management on their tasks, on their application. So there is definitely education here that has to happen in order for people to effectively use it and not just to run the test to say that they've run the test, right? And we had learned that already with quality assurance when we started to make quality everyone's responsibility. And so that's the model that we've used. Your first one was about the load balancers, and I think, Sean, you probably are best to answer the question about the load balancers and how we grouped applications.
Yeah, I don't know what number we're at, but we certainly, I think the cost savings we're seeing is, we said 65%. I think we're actually getting higher than that as we finish the migration from our version 1 over to version 2. I think we're probably 70 to 80%. So we've been able to significantly reduce the number. I don't know how many we currently have, but it's been a significant mapping using the ingress controller to get the alignment better.
And I would say a lot of it has to do with the accounts that the applications sit in,
Right.
where they communicate, who they communicate to, not just randomly, we're going to put these 10 applications together.
Right. They're all aligned
at
the product model. So we tried to align a load balancer at the product level and consolidate it that way.
Yeah.
One of the other things, if I could add to your first answer a little bit, when we think about chaos testing and performance testing, ultimately a lot of those capabilities you want to do as a minimum, just a minimum set as part of the automation that you provide. Okay, so how do you, to your point,
Yeah.
Instead of educating everybody, you may have to do that for a number of these applications that are highly performance critical or require a great deal of chaos testing. But also building that into your pipelines and building that into your constructs, our paved paths, to enable a developer team to either call an API to just say run performance testing and then it runs a certain set, or chaos testing, right? That provides a tremendous degree of value because now, again, you're using this consistent pipeline and architecture to get that to span.
And you're making sure that the resources come down afterwards, by the way, because it turns out engineers are really bad at remembering to decommission resources. Any other questions? Oh.
Please join me in a high watermark round of applause for Sean
Thank you.
Thanks for watching. Check out more FinOps X 2024 content on our YouTube channel on the 2024 playlist. Support our channel by liking, subscribing, clicking the notification bell, and by leaving comments and questions for our speakers. We appreciate your support.